Okay, had any of you looked at campus, or not campus, plan book before you came to school today? Okay. Obviously, with having yesterday off as a snow day, and yeah, we might have snow days, but that doesn't mean you have the day off. Does that sound right? Maybe you have to do things around your residence or something to that effect. Yes. No. Okay. But after tomorrow, okay, I don't think there'll be any problems the rest of this week. We could have late starts, I think, but I believe it would not affect this class because if we have another late start, it would be my understanding that we'd go to first and second, and then it would be lunchtime. I think that makes sense, right? Okay. So the way the rest of this week will unfold is we're going to talk about an activity that we were going to try to get in last week, but that didn't happen. We have people catching up on the combined gas law. We'll get that back to you, and we'll have an evaluation, a short evaluation on Thursday. Okay, so tomorrow we'll be over in the lab doing an activity, and then what will happen is our evaluations over this chapter are next Tuesday and Wednesday. Okay? Now, that's when it is. For some odd reason, should we not have school on Monday, we're still going forward as planned. Okay? Does that make sense? Okay? Should it happen like with last hour for the freshmen, how many of you looked up and remember those balancing chemical reactions? So I try to tell them, if you don't understand, find an upperclassman, come in and talk to myself, do whatever it is you feel it needs to be done. Well, what I told them is I did a few problems after the bell had rang, and for those who choose, can come back to the science channel and see some examples that we did not work on together. So should that happen, chances are I'll do my best to perhaps put a couple of questions on Monday where we don't have school. Go to the science channel and just make sure I know what I'm doing so that whether we have school or whether we don't, we're proceeding forward with that evaluation on Tuesday and Wednesday. 2 parts. Okay?
Would you post the video on Monday then?
Yeah. Yep, I would do my best to do that. And I'm not quite sure how that will unfold because it's one of those things to where when you log on to something, chances are it's your email or whether it's your social media accounts. I try not to do the one where it says save login and password. When you create a new account, how many of you do that? You hit save. Yes, I don't want to remember my login and password. Okay? That's got its advantages. It does. But on the other hand, I try not to do that. I haven't tried this from home. There's really no reason to believe that I would not be able to do that. The only problem with that is I don't have anything like this at home. The laptop that I do have, I don't know if I can get onto our personal network at home with this laptop. Maybe I could. Maybe I'll just bring both of them home. Because it's getting to be to the point where either one, we're going to have to cut our losses, or two, you're going to have to start doing examples or problems outside of class on your own time. And for instance, for the freshmen, I handed out a paper today, and as you know, usually it's due 2 days later, which it is, but we're not going to have any issues with that this week. But probably for them, when it came to these chemical reactions, what 2 things do you think you were responsible for when you had to do those as freshmen? And you still do it as juniors in general chemistry, but we just go a little faster. What might that be? You had to, well, Well, true. You need to balance the reactions, and there are how many total reactions you needed to know. Break apart. Decomposition. 5. That's right. So, for instance, for them, I'll probably hand that out on Thursday. No school Friday. And if I was to believe the weatherman or just believe how things are going with how Mondays have rolled around, we might not have school again on Monday. But it's one of those things to where I don't, it's going to have to be a personal choice whether you choose to, I want to say, take the time and do that. Some yes, some no, but regardless. Okay, so the activity that what we want to do tomorrow is with one of Charles's gas law, okay? Because it's one of those that you had answered correctly, and we know that we can make one gas law is a direct relationship, the other one is an inverse relationship, but which one is which? Yes. Okay. So, for instance, one of the things that of course a person would notice when you're carrying these plastic jugs from outside, okay, just from your vehicle, the moment you step outside and you're walking along and you just, what happens to this container? Why is it shrinking? So what's that going to do to the gas in here? It's going to cause it to not drop it. It's going to cause, I did that on purpose. Okay, so it's going to cause the gas to, I don't want to say shrink. That's not the word I'm looking for. Not condense. Contract. Contract, I mean, because the opposite of that is expansion. Okay, so we do something very similar to that. So this is a side view, okay? For instance, if you could cut this desk in half and it would still stand up, but what that allows you to do is get a side view, looking in from the side. So this is a side view of your sink, okay? Of course, it's just a simple box like this, okay? And what happens is you will have approximately, I'm guessing, we'll just say 17 degrees centigrade water in there, okay? Because we know at 0, it's going to start to freeze, okay? So the reason that's important is you take an earthenware flask, okay? Let's get a little lopsided. I think if I went and got one, it'll make a little more sense. So just bear with me. I did not do very well in art class, as you can tell. That's what this is supposed to be, okay? That's what this was supposed to be up here. As you can tell, I kind of failed a little bit, but you kind of get the idea, okay? So what that means is what you have to do, it says 250 milliliter Pyrex, okay? When it says Pyrex, that's something that has an additive in this glass that when it's boiling, well, if it's holding a substance that's boiling like water, you can put that in a cold substance and it's not going to crack or shatter. Okay, that's why it's important to use Pyrex for that. And what that means is this will be on a ring stand. Okay, that's another part of so here's your ring stand, and then you've also got a Bunsen burner. There's your flame. Okay, and then this is over top, and it sits in a 600 milliliter beaker. Okay, so as this is sitting on top of here, okay, as this is sitting on top, well, it looks like one of those emojis, don't it? Okay, I didn't plan that, but so this holds, like it says, 250. Now, that says 200 to this increment right here, but it doesn't necessarily mean that it's going to be 50 from that increment all the way up to the top. Okay, it's going to be somewhere approximately. So what you would do is you can safely measure, once you fill it up to this mark, we know that that's 200, of course, because that's what the increment says. And what you need is a stopper that has a glass tube sticking out of it, and that might even make more sense because I keep them in the same place in the lab. So again, please just bear with me. I'll return shortly. Okay, so we're back. So again, you can see the same type of material here, but this has this glass straw sticking out of the top. So we had already mentioned that we need to know how much water this will hold to the bottom of this rubber stopper. You can see the last group that used this, there's a few marks on there because some people want to again, so it gets a good tight seal. So there's the bottom. You can see some of that red markings on there. So what you need to do is determine where you think the bottom of that rubber stopper is. Okay, put a mark on there. Then start filling this. Get all the way up to 200. As we said, we know that's 200. Then fill it all the way to the bottom of that mark that you just made. Does that make sense? So let's say, for instance, you got that up to 200, and then you add 46 more. Well, you're going to say, well, it says 250 on here, but remember, you can't fill this up to 250 because that rubber stopper is on here, right? So that's maybe taking up that 4 milliliters of volume, okay? So let's say that that's the case. That is volume 1 equals 246 milliliters approximately. Okay. So you have this. Once you've determined that, then you empty the water out of there. Put this on your ring stand in that 600 milliliter beaker. Submerge it into water. Okay. And you leave that in that beaker for 15 minutes or so would be fine. So what's happening to all the available air inside this container as you're heating that up in boiling water? What's the air doing? It's going to expand. So that's going to all escape through the top of this straw, which is fine. That's what we want it to do. Okay? So then, since we're talking about degrees centigrade, temperature 1 should be approximately what on top of here? So when does water boil? So then in kelvins, okay, so there's our temperature 1, okay? Then, why do you suppose this number in the sink is important? Nope. What's this also? It's a cold water bath, so it would be temperature what? Temperature 2. Okay? So temperature 2 would give you approximately what? 290? Right? So then, what are we finding according to Charles's law with the information that you see? Volume 2, so that would be your question mark. So if you remember from general stoichiometry, we did something kind of similar. You just did a chemical reaction. And then on pencil and paper, like the information that you see there, okay? On pencil and paper, what type of yield are you going to calculate? Theoretically, according to Charles's law, we should get a specific number with this. Do you suppose you're going to get the same with what you calculate? No. When you actually do the experiment, after this has been on the Bunsen burner, in your 600 milliliter beaker, in boiling water, that's why it's got, I can't remember the proper term, it's a, I wouldn't call it a ring stand holder, maybe a flask holder that attaches to this rod here. So you take this off with your holder, okay, and then, this is important because if you don't do this right, your results are going to be inaccurate. So my thumb and forefinger are the flask holder. You take that over, you invert it, okay, put your finger on that glass straw or glass opening or whatever. You submerge it in this cold water bath, okay, let your finger go. What do you think will happen when you have such a drastic temperature change between these? When gases get cold, what do? Not break. They contract. So when that contracts underwater, it's going to create something. What's suction called? Say that again? It's going to create a vacuum. So that's going to suck water up into here. So when you say this lab sucks, you can say, this lab sucks because you're creating a vacuum. We told a funny. Laughter and or humor and science going hand in hand again. It's gonna be cold. I think we've got an ample amount of snow we can throw in there. There's been times where we got to go to the, not the training room here, but to the ice maker and grab some ice to throw in here. But like I said, we don't have that problem now. So we've got plenty of snow to throw in there to get a cold water bath going. Okay? So then what that means is after your vacuum has pulled as much available water in there, let's say okay, so here's the water level in your sink, okay? So then what you're doing is as you're holding this underneath, once no more water is flowing into here, okay, what you will do then is put your finger back underneath, okay, or you're going to want the level inside of here. Maybe it, God, I thought that was stuck in there better than that. I think it ruined it. But what that means is then maybe it's up to this 150 mark, okay? You put your finger back over top of that, turn it over, okay? Then what you're going to want to do, okay, is measure how much water you're adding from that point up to this mark again. And then that will give you volume 2. You compare that to what you just made. Okay? That is essentially what you're doing. So, with that, are there any questions over this? Maybe you don't know what to ask. This, Yeah, but the holder's gonna be, that's what you grab it with. You don't grab it like this with your hand.
Yeah, but then when you flip it upside down, just put your finger over the straw.
No, that's not gonna be hot. No. It's gonna be warm, but it's not gonna be so hot that you can't put your finger over the top of it. Okay. I got a little bit of work to do on this one. I wish that hadn't happened, but it's cracked all the way through. I think this one's shot now. I'm the one that broke it. Darn it. Okay. So, with that, that's what we're going to be doing tomorrow in the lab, and we'll probably do about 3 trials. One of the things you can do is you can always alternate this. You can drop that temperature as closer to 0 as you want. You're not going to change this one, but you can change that one by just adding more snow or what have you. You can. Yeah. So any questions? Again, maybe you don't know what to ask.
That's volume too. So when you like tip it out and you take it back out of the water,
Mm-hmm.
you just measure it again.
Yep.
You don't have to like subtract anything. You just like.
You can do it one of 2 ways. You can measure, okay. What you can do is measure what you take out and subtract that from 246. Or you can just keep track of how much you added to the bottom of that mark. It'll give you the same answer. I just think that keeping track of how much you added is easier. But yeah, you can measure how much you've taken out and subtract the 2. Whichever one you want to do. Maybe do one way, maybe do one the other. Less. Less.
Taking it out.
Yes.
Yeah.
Okay. All right. So that's what we'll be doing tomorrow. And we should have some time to we'll maybe do a question or 2 in the lab that deals with the combined gas law. Your evaluation, short evaluation of combined gas law is on Thursday. Evaluation over the entire chapter is then on Tuesday and Wednesday of next week. Even with no school on Monday, Tuesday and Wednesday we have exams in here. Yes. Yes. Alrighty. We'll pick up with this in the, unless you want to go over a question over the combined gas law now, that's entirely up to yourself. You've got the time, but that's entirely up to you.